In this video, we're going to be talking about the relationship between the position, velocity, and acceleration of an object, and how the derivative can help us define the velocity and acceleration of the object given the position. In this first example, we have an object that is moving horizontally along an axis, and its position function is given by t cubed minus 9t squared plus 24t plus 4, where t is greater than 0. So before we get into this problem, let's review if we are given a position function, s of t is position. If we talk about the rate of change of position, how fast the position is changing, that would be the velocity. Right? Velocity is the rate of change of position, and we now know that rate of change can be found by taking the derivative. So if the velocity is equal to s prime of t, that's the derivative of the position function. And velocity can be positive or negative, and speed, on the other hand, is going to be the absolute value of velocity. So velocity can be positive or negative. A positive velocity would mean either it's going up or it's going to the right, depending on if it's horizontal motion or vertical motion. Velocity positive means going up or going to the right. And velocity negative would mean that it's either going to the left if it's horizontal motion or it's going down if it's vertical motion. So velocity, again, is the first derivative of the position function. If we talk about how fast the velocity is changing, that would be acceleration. So acceleration is the rate of change of the velocity. So that would be v prime of t, or you could think of that as the second derivative of the position function. So now that we know that, let's go ahead and go back and tackle this problem. We first want to find v of t, and so v of t we know is the derivative of s of t. So it's going to be the derivative with respect to time of t cubed minus 9t squared plus 24t plus 4. And so again, you may need to go back and take this step by step with your derivative rules, but the answer is going to be 3t squared minus 18t plus 24. That is our velocity function. And it's going to vary depending on what we plug in for t. It's now asking us, at what time is the particle at rest? What would the velocity be if the particle is at rest? Well, it would be 0, right? So we're not going to plug 0 in for t. That would tell us what the velocity is at time 0. Instead, we want to plug 0 in for v of t. We want to find out when the velocity is 0 and then solve for t. So we're going to set 3t squared minus 18t plus 24 equal to 0, and then solve for the t value. And I can do that by factoring out a t. I get minus 6t plus 8, and then I factor that, 3 times t minus 4 times t minus 2 equals 0. So that means that t minus 4 equals 0, t minus 2 equals 0, and that means t equals 2, or t equals 4. So at both of those points, at 2 seconds and at 4 seconds, this particle is at rest. And I'm assuming it's seconds, although it does not say seconds. So it could be minutes, I guess. But nonetheless, we have t equals 2 and t equals 4 are the times at which the particle is at rest. Now it's asking on what time intervals is the particle moving from left to right and from right to left. What I'm going to do at this point is to use a very handy technique that I use, and that is to draw a number line. And we know here's 0, it starts at t equals 0, right? And then it goes to 2 seconds, and that's when the particle's at rest again, and then at 4 seconds the particle's at rest again, and then it doesn't change again. So what I want to do is I want to test. Remember what I just said, that if the velocity is negative, the particle is moving to the left. If the velocity is positive, the particle is moving to the right. So I'm going to take a point between 0 and 2 seconds, and I'm going to test the velocity. Okay, so what's a point between 0 and 2? We can pick any point we want between 0 and 2. But what if we pick point number 1? And I'm going to find the velocity at 1 second. If I find the velocity at 1 second, I'm going to get 3 times 1 squared minus 18 times 1 plus 24. And we're not really concerned about the value. We're just concerned about whether this is positive or negative. Okay, so this is fairly simple to calculate. But I'm going to get 3 times 1 squared is just 3. And I'm going to add that to 24, so I get 27. And then I'm going to subtract 18. If I take 27 minus 18, the value I'm going to get is going to be positive, isn't it? So I put a positive sign here. Now we want to test so what does that tell us about the velocity between 0 and 2 seconds? It's positive, and that means it's moving which direction? It means it's moving to the right, isn't it? Okay. How about between 2 and 4? Let's take 3. So if I find the velocity at 3 seconds, I'm going to get 3 times 3 squared minus 18 times 3 plus 24. And it may take me a minute to solve this, so I'm going to get my calculator out. And what I get is 51 when I add my two positive numbers together, minus 54, which is a negative number, isn't it? So it's negative here, which means the particle is traveling to the left. And then after 4, if I take the value 5 and I plug it in, I get 3 times 5 squared minus 18 times 5 plus 24. And if I solve that, I get 99 minus 90, which is a positive number. So it's positive over here. So again, it's moving right from 0 to 2 seconds, and then it stops, and then from 2 to 4 seconds, it's moving left, and then it stops again, and then it's moving right again from 4 seconds on. So if I had to write this as intervals, I would say it's moving right over the interval from 0 to 2, and from 4 to infinity, and then it's moving left over the interval from 2 to 4. And notice that I do not include my endpoints, because at those endpoints, it is actually, the particle is at rest. It's not moving either direction. In the second problem, we're actually looking at vertical motion. So we have a rocket that is fired vertically upward from the ground, and the distance s in feet that the rocket travels from the ground after t seconds is given by the position function s of t equals negative 16t squared plus 560t. And they're asking us to find the velocity of the rocket at 3 seconds after being fired and find the acceleration of the rocket 3 seconds after being fired. So here we have s of t equals negative 16t squared plus 560t. We know our velocity is the derivative of the position function. And that's equal to negative 32t plus 560. And then we know the acceleration is the derivative of velocity. So it's going to be the derivative of negative 32t plus 560. And that's equal to negative 32. So the first question is, find the velocity of the rocket 3 seconds after being fired. And so that means we're finding v of 3. And so if I plug that in, what do I get? I get negative 96 plus 560, which is equal to 464. And we're talking velocity here, so we know our units, feet per second. So it's moving at 464 feet per second. And the fact that it's positive tells us what? It should tell you that the rocket is still moving in the upward direction. Remember, velocity positive means the object is going upward, and velocity negative means the object is going downward. All right. So now they're asking, what is the acceleration at 3 seconds? And you can see that there is no variable in the acceleration function. So that means that it's always going to be constant. It's going to be negative 32, and that's feet per second squared.